Hello friends, welcome back. In this video, we are going to do question number 9. So let us start. F is the point 5, minus 2 and Fg is equal to minus 2, 3. Find the coordinates of the point G. So F is the point 5, minus 2. If the origin is 0, 0, then OF bar is equal to 5 minus 2 and FG bar is equal to minus 2, 3. And they are asking the coordinates of the point OG bar. So what do I know? OG bar is equal to OF bar plus FG bar. That is equal to 5 minus 2 plus minus 2, 3, which is nothing but 5 minus 2 minus 2 plus 3. And this value is equal to 5 minus 2 is 3, minus 2 plus 3 is 1. And so the point G is 3, 1. That is how you solve it. Next, 5 into Fg bar. So they have already given Fg bar, which is minus 2, 3. So 5 into Fg bar is equal to 5 into minus 2, 5 into 3. You just simply take each coordinate and multiply it with 5. This is equal to minus 10, 15. So the answer is minus 10, 15. And the third part, modulus of Fg bar. So the modulus of the vector AB is equal to square root of A square plus B square. So the modulus of the vector minus 2, 3 is square root of 2 square, which is 4, plus 9, which is square root of 13. And square root of 13, its value would be in between 3.605 and 3.606. So the answer is 3.605. So this is the value. So I can calculate it using the calculator and then write the value, right? So this completes the modulus. Now let us go to B part. OABC is a parallelogram. OABC is a parallelogram. That means OC bar is equal to AB bar is equal to C bar and OA bar is equal to CB bar is equal to A bar. Okay, so these two are given. Now P is a point on AC and Q is the midpoint of AB. Okay, find in terms of A and or C AQ bar. So Q is midpoint of AB bar, and so therefore AQ bar is equal to half of AB bar, which is nothing but half of C bar, and so AQ bar is half into C bar. Very straightforward question. Because it is a parallelogram, opposite sides are equal vectors, and so since OC is equal to C bar, AB will also be C bar. Now AQ is half of C bar. That's it, straightforward. Now we want OQ. So we have already known what AQ is, so we can start at O and we can go to Q. So this is the path that we will take. So we will take OQ bar is equal to OA bar plus AQ bar, and OA bar is A bar, AQ bar is half C bar. So OQ bar is A bar plus half into C bar. Okay, this is also straightforward. Now OP bar is given to be 2 by 3 A bar plus 1 by 3 C bar. Show that O, P and Q lie on a straight line. Okay, so we need to show that they are parallel vectors and that they have O as the common point. So OP bar is equal to 2 by 3 A bar plus 1 by 3 C bar. This is nothing but 1 by 3 into 2A bar plus C bar. Now what do we know? We know from the previous answer that OQ bar is equal to A bar plus half C bar. So if I take this as half, that means half into 2A bar is A bar plus half has come out, so it is C bar. So we can see that OP and OQ are multiples of same vector, which is 2A bar plus C bar. They are multiples of the same vector 2A bar plus C bar and have O as common point. So if they are multiples of the same vector, that in itself means they are parallel vectors. And two parallel vectors having the same line, having the same common point, are the same line. So OPQ are collinear points because they have a common point. If they don't have a common point, then they are parallel vectors. But since they have a common point already, they are collinear points. Write down the ratio OP is to OQ. So OP bar is equal to 1/3 2A bar plus C bar and OQ bar is equal to half 2A bar plus C bar. Therefore OP bar divided by OQ is equal to 1 by 3 divided by 1 by 2, which is 2 by 3. And this 2 by 3 we can write it as 1 by 3 by 2. So therefore OP is to OQ is equal to 1 is to 3 by 2 and the ratio is 1 is to 1.5. Okay, so 3 by 2 is nothing but 1.5 and so the final answer is 1 is to 1.5. This is a straightforward question. The point that you should know is if two vectors are multiples of the same vector, then they are parallel in every case, and if they have a common point, they are collinear. Because two parallel vectors having the same point means we are essentially talking about the same line, right? That's it. And let us meet in another video. Until then, all the best. Thank you.